I made a Minecraft clone with full ray tracing in C++ with Vulkan. Here's how it went. This project originally started out with the goal of being a path-traced Wolfenstein 3D knockoff. In case you don't know, path tracing is a technique for lighting where you essentially simulate thousands of individual rays of light as they bounce off surfaces. I'd only ever worked with OpenGL before, so I wanted to try out a different API. I got the essentials working using DirectX 11, but then I started to run into path tracing's biggest flaw: noise. Since the direction that rays bounce is random, sometimes a ray can go straight into a light source and sometimes it gets trapped bouncing around in a dark corner. To counteract this, you can sample multiple rays per pixel and average the results, eventually converging on the correct value, but it can take a lot of samples to look smooth. To get a good result, the sample count has to be in the hundreds, thousands, or even hundreds of thousands, and this obviously has a pretty big impact on performance. There are a lot of techniques to help smooth over a noisy image, like using samples from previous frames, biasing rays to bounce in more impactful directions, or AI denoising, but these all produce annoying artifacts and performance still wouldn't be that great. So I decided to leave it there and move on to the next project. Having learned the basics of DirectX, I decided to move on to Vulkan. I'd always liked the look of those old 90s CG renders. Unlike modern renders, these didn't use path tracing. Instead, they only used a few rays for reflections, refractions, and shadows. This loses the soft, realistic lighting, but would be much faster than full path tracing. I followed a tutorial and read the docs to get a basic triangle working in Vulkan. Then I started adapting my shader from HLSL to GLSL. I had already gotten ray tracing in a 2D grid, so now all I had to do was add an extra dimension. Pretty quickly, I hobbled together a shader that would ray trace into a voxel grid stored as a 3D texture, then just stuck that shader on a rectangle covering the entire screen. Here I started to do some stress tests. Even with a large map size, performance was pretty good. So I added a 90s looking checkerboard texture. Not an actual texture, but just code to change the color based on where the ray hit. Then I added one of the main advantages of ray tracing: reflections. I also added an approximation of the Fresnel effect, which is a phenomenon where surfaces become more reflective at sharp angles. I tested adding a texture to the cubes, just an iron block, to see what a metal surface would look like. I used the ppm file format for textures. It's pretty much just raw pixel data with zero compression. And this is where I decided to make it a little bit more like Minecraft. I added block placing and removing, as well as a crosshair. So far, the only way to look around was with the arrow keys, so I also added mouse input. I started working on adding collisions as well as refractions. For now, I added a second block type, which was transparent but changes the direction of the ray. And then I left it to rot for over a year, until I decided to make a YouTube video about it. I initially didn't really want to polish it up, just make a quick video to be done with it, but I needed an image for the thumbnail, so I quickly changed the world generation to create a flat plane. And a house made of just iron wouldn't look so great, so I thought about changing the block texture to grass. But as I was doing that, I realized it wouldn't actually be very difficult to hardcode a few extra blocks in as well. I made a materials array in the shader and had the block ID select the material, allowing different blocks to have different properties. But as I kept playing, I couldn't help but add gravity, collisions, and normal maps. The final version has grass, iron, wood, cobblestone, glass, and mirror blocks. There's a lot more that could be done with this. For example, I only realized at the end that I completely forgot to account for refraction when a ray exits a material, so the refraction code is entirely wrong. And there are still a lot of problems with things like there not being reflections of reflections, but I also have a feeling that implementing that properly would completely destroy performance. Anyways, the final code and a download is linked in the description. If you decide to play it, there might be some crashes on certain systems. This was my first project in Vulkan, and I doubt I did everything correctly. But some of the code is over a year old at this point, and I really don't want to touch it anymore.